This is Unit 2, Block 4. We're going to be doing Example 2 and Example 3. In Example 2, we are given information about a revenue function and a cost function where we're plugging in N, representing the number of widgets sold in thousands and also the number of widgets produced in thousands. So it first asked us to find a profit function, and we know that profit is revenue minus cost. So we need to take the R of n function minus the C of n function. So we're going to take that top function minus this whole bottom function. So the profit P of n will equal negative 29n squared minus negative 2n squared. So that's really taking the negative 29 plus 2, we'll get negative 27n squared. And then 1450 minus 152, that'll give us positive 1298n. And then 3000 minus 199, that will give us positive 2801. So now we have a profit function. It then asked us to find the derivative of R, the derivative of C, and the derivative of P. So we have each of the given functions. We'll just use our shortcut rules to find the derivatives. So the derivative of R, we're going to drop down that 2, and we're going to get negative 58n plus 1450. We're going to take the derivative of C of n, so we get negative 4n plus 152. And lastly, we take the derivative of the profit function, so we get negative 54n plus 1298. It asks us then to just do some evaluating, find the revenue and marginal revenue, cost, marginal cost, profit, marginal profit at n is 24.512. So I went ahead and I put all of this in Excel so that we could evaluate each of these 6 functions at that input value. And over here we see them. I plugged in n is 24.512, and I just popped those functions into Excel. So I've just given all the values here that I found in Excel for the revenue, cost, profit, and the derivatives as well at those points. So now we want to interpret this. So we're saying here that the input value is 24.512. In the problem, they said that the input represents the number of items in thousands. So we're talking about producing and selling 24,512 items. At that instant, they have total costs of $2,723.15. They bring in a revenue of $21,118.09, thus having a total profit of $18,394.95. Revenue minus cost equals that $18,394.95. So the derivative values are telling us marginal revenue, marginal cost, marginal profit. They're telling us the increase or decrease in revenue, cost, and profit for producing the next item. So we're saying if they increase n by 1, then you will see a decrease or an increase in revenue, cost, profit of these values. So notice here the units. We have units of n thousand items, and the output here is in dollars. So really we need to interpret it that way. If you increase n by 1, it's really increasing by 1,000 items. So it would probably be good when we do our interpretation to really break this down. I'm going to take these amounts and divide them by 1,000 so I can really interpret this in terms of dollars per item rather than dollars per 1,000 items. So if I divide each of these by 1,000, I'll get here 0.028 dollars per item for the marginal revenue. I'll get 0.054 dollars per item for the marginal cost, and I'll get negative 0.026 dollars per item for the marginal profit. So they're saying producing and selling the next item. So that would be the 24,513th item. That will increase revenue by about 3 cents, so 2.8 cents. that will increase costs by about 5 cents, 5.4 cents. Notice the costs went up more than the revenue went up. Therefore, the profit actually goes down. They're going to bring in less money than they actually have to spend on that next item. So profit goes down. So we want to look at that profit function. This is a graph of the profit function. Down here on the horizontal axis, we have the input is n thousands of items. That's thousands of items produced and sold. The output is the profit. And so they're saying we're going over here to about 24.512, which is about right here. And we're plotting that point. We found that that point on the profit function was inputting 24.512 and it's outputting a height of 18,394.95. And at that instant, it's actually going down. The profit is decreasing at a rate of 2.6 cents per item. Let's take a look at the next example, example 3. So it says a publishing company estimates that when a new book by a best-selling author is introduced, its sales will be modeled by this function n of x. X is the number of weeks after release. N of x is the number of books sold that week in thousands. So it first asks to find n prime. I'm going to, before I dive into finding the derivative, just note that n of x can be rewritten in a little bit easier manner. Remember when you have a square root of x, you should rewrite that as x to the 1/2 power, because then we can see easily that it's a power function, and we know how to find the derivative of power functions. So I've rewritten the n of x function in this manner. Now I'll find n prime of x. I'm going to take that 68.95 times 0.5, dropping down that exponent. I get 34.475. And then I take that exponent 1/2 and subtract 1. So I get negative 1/2. And the derivative of 0.125x is just 0.125. So there's the derivative. I need to find n of 52 and also evaluate the derivative at 52. So I'm just going to pop that either in your calculator or pop it into Excel and get the answer out. And I got n of 52 is 503.706 and prime of 52 is 4.906. Interpreting this. So the input is 52 weeks. 52 weeks is exactly 1 year. So 1 year after the release of the book. N tells us the number of books sold that week in thousands, so that tells us they sold 503,706 books that week. And prime of 52 tells us the rate of change at that instant. It's positive, so we know that the function is increasing. The number of books sold is increasing. So at that time, book sales are increasing at a rate of 4,906 books per week.